So thank you, Merle, for the warm introduction and for organizing this very wonderful and interesting conference. For me, it is very exciting to see the researchers I used to read and admire their work. Hi, everyone. I'm a PhD student under the supervision of Professor Simon Shamai Tsuri from Haifa University, Israel. And today I would like to talk about my recent publication and discuss whether herding in human groups is related to high autistic traits. Why isn't it working? Just a second. Okay. So we can see group herding throughout evolution in lower life forms as it provides beneficial outcomes to the individual's fitness. In humans, joint synchronized actions such as dancing, playing sports, conversing, and even walking together down the street comprise a great deal of our everyday social lives. And as it's probably known by all of you, herding behaviors like other alignment behaviors enhance the group's sense of unity, solidarity, and emotional well-being. There are three principles presumed to guide herds from reptiles to mammals. So first, aligning with the direction of movements of those that are close by. As you can see here in the right image, the fish is misaligned in his direction of movement compared to the other fish. By changing the direction of his movement, he can align with his group. We suggest that the system that is in charge of this kind of action is the interpersonal synchrony system that facilitates and regulates group synchrony and alignment. These second and third principles that are involved in herding are cohesion and separation. Both are regulated by the system of interpersonal space. We suggest that at the same time the fish is aligning his movement direction, he also needs to maintain group cohesion by approaching other individuals in his herd. As you can see here in the second image, the fish is in the right course of movement with his group, but he is in great distance from them. So he must approach the group in order to be more cohesive. However, he must keep a certain distance from the other members of the group to avoid intrusion. So therefore, he must maintain also a separation interval. So these two simultaneous processes of approaching and maintaining minimal distance are evident in approach and avoidance behavior. And I will address all of these measurements and principles in the later section of the analysis, so keep them in mind. Another distinction that I would like to make is the distinction between spontaneous and intentional herding. Spontaneous herding emerges unconsciously when there is no explicit social goal of synchronization. For example, in phase clapping of an audience, unintentional synchronous walking, or dancing together to a rhythm. In contrast, intentional herding includes conscious and intended synchronous presentation involving planned movement alignment, such as dance routine, coordination of musical ensembles, and marching soldiers. Though intentional and spontaneous synchrony share considerable similarities, these are two distinct abilities. They distinct in the extent of awareness to others' action, the level of monitoring that is required, and the presence or absence of the goal. Intentional synchrony involves elevated awareness to the other's action while purposely attempting to align with others, whereas spontaneous synchrony involves low efforts to adjust, minimal awareness to others' action, and no specific goal. Thus, we claim that individuals' spontaneous herding performance is not necessarily bound to his or her intentional performance, meaning that one can display an excellent ability to intentionally herd with the others, but doesn't necessarily mean that he could also have an excellent ability to spontaneously herd. Although, as I initially stated, herding may occur naturally in groups, but under certain conditions, some degree of impairments leads to reduced tendency to herd with the group. Autism Spectrum Disorder, or ASD, is one of a growing category of neurodevelopmental disorders marked by potential dysfunction in herding. Individuals on the autistic spectrum disorder present deficient reciprocity during social interactions, impairments in nonverbal communication, and difficulty to adjust to social context. It's been proposed that ASD traits exist in the general population, exhibiting the same etiology along a continuum. So studies show a variation in ASD-related traits among healthy individuals across the entire population. Therefore, in the current study, we were interested in studying typically developing individuals with high autistic traits, as we assume they will display similar difficulties related to ASD, but without the additional variables that can influence performance, such as comorbid disorders, motor impairments, or impaired intelligence. Another motive for the current study was our desire to understand complex social behaviors in groups that includes individuals with ASD traits. Up to date, most of the literature regarding ASD has focused mainly on dyadic interactions and specifically a caregiver and a patient dyads. And therefore, the question whether individuals with ASD or ASD traits exhibit impaired hearing during a genuine group interaction remained unanswered. And we further wanted to examine spontaneous and intentional hearing as two distinct abilities. So to examine these questions, we developed a new computerized social task in our lab. The procedure included a group of 4 participants at once. So in each session, a group of 4 participants are seated together in a room. Each participant is facing his own computer screen, and all 4 computers are connected through a server to a network. So basically, the participant could interact with one another in real time using the computer. Each participant was assigned to a differently colored circle, red, blue, green, or turquoise, and could move a circle across the screen using the 4 arrows on the keyboard and all of their combinations, so creating 8 movement paths. So while the participant was moving, he could see the movement of all the other players as well and interact with them. We specifically requested all of our participants to engage in interaction that is happening, I'm sorry, only during the using the digital platform that we've provided, and refrain from talking or communicating any other way. And all the data was collected at a sampling rate of 5 Hertz. So the task included 2 conditions, a spontaneous hearing condition and an intentional hearing condition. Each condition lasted for 3 minutes. So in the spontaneous hearing condition, participants were instructed to move their circle freely by means of the 4 arrow keys. And while they're moving, they had no other instruction. They could do whatever they wanted. However, in the intentional hearing condition, participants were again instructed to move, only this time we explicitly asked them to synchronize with each other as a group. We had 136 participants randomly assigned into groups of 4. It is also important to acknowledge that the groups varied in their composition. Each group had its own set of characteristics. We did not control for age, gender, degree of acquaintance, or ASD traits. So we had a random variance for each foursome that we presume that since we had a random assignment, this random effect is normally distributed between the different composition. However, this random variance might also affect the performance, and therefore I will address this part in the analysis and results section later. So all participants completed the Baron-Cohen AQ questionnaire to quantify their degree of autistic traits prior to the task. The AQ questionnaire is a well-established self-administered instrument that is commonly used for measuring the degree of autistic traits in the population. And for the analysis purposes, we divided our participants into two groups of high and low autistic traits according to the AQ median score, which corresponded also with the mean AQ score in the general population. So we also had a good variance in AQ score ranging from 7 to 29. So here I brought you short videos so you can see the task in the different conditions. I will start with the spontaneous herding condition. So you can see that the movement is pretty individualistic with occasional moments of alignment between the participants that move freely and keep certain distances from one another. In the intentional herding condition, you can see that the circles are much closer. They're moving in the same rhythm and direction and create a clear joint pattern of movement. And here you can see the spatial pattern of movement in both conditions. Each color represents the course of movement of a specific individual in a specific foursome for the entire session. So you can see that in the SH condition, the spontaneous herding condition, the image is quite chaotic on the left, though there are times in which the different lines of color are close and similar, suggesting some moments of herding. Whereas in the intentional herding condition on the right, you can see that participants clearly moved together, creating a noticeable joint of pattern. And it is important for us since this is a novel task. These findings help us verify that our participant indeed followed the instruction, they understood the task, and more importantly, they were able to herd using the digital platform that we've provided. To statistically examine our paradigm and verify that we were measuring herding behaviors that is above chance level, we created pseudo groups. We reshuffled the participant movement pattern and assigned them randomly into new groups of 4. So these groups were pseudo groups that consisted of participants from each different real group. For each participant, we calculated eventually 2 sets of measures. One based on the real group of participants he had performed the task with, and one based on the pseudo group that the participant had been assigned to. So now I will go over the measurement we obtained from our task that are related to the 3 principles I've presented in the beginning of the talk. So these principles include alignment, cohesion, and separation. And we created 3 variables to estimate each component. To measure alignment between each individual and the group, we calculated the directional correlation, which is the cosinus of the angle between the velocities of 2 players. So we've calculated the directional correlation between each participant and each of the other participant in his group, and then calculated the mean correlation for each participant. Higher correlation in these measurements indicates stronger tendency for herding. Cohesion was assessed using the distance in centimeters from a shared center of mass. So smaller distance between the participant and the shared center of mass indicated a stronger tendency for herding. So smaller distances indicate greater herding. Separation was examined by determining the minimal distance, again, in centimeters, each participant maintained from the other participant. So here again, smaller distances between the participants and the other participant or other group member indicate less separation between individuals and hence stronger herding. It is important to note that all of the measurements were calculated at 0 leg for 2 reasons. First, we statistically examined the maximal correlation of the corresponding legs in second and found that the highest correlation between participants was indeed at 0 leg. And the second reason is a theoretical one, since herding occurs in the here and now, and we did not expect any legging. Okay, so moving to the results. So first, to validate the paradigm and also examine the emergence of herding, we compared interaction that happened in real life as opposed to the pseudo setting in which interaction in essence did not take place. As I previously said, we had two types of assignment, a real assignment and a pseudo assignment. So in these graphs, you can see the mean z-score in all of the herding measurements in the two conditions, the SH and IH conditions. Since greater distances in cohesion and separation measurements indicated decreased herding, we multiplied these values by -1 so that higher z-scores in all of the herding measurements will indicate higher herding. So in the upper graph, you can see the spontaneous herding condition, and in the lower graph, it's the intentional herding condition. So as you can see in the blue graphs, they represent the directional synchrony, meaning the alignment component. And you can see that in the real assignment compared to the pseudo assignment, the directional synchrony is higher, indicating greater herding. The same thing happens with the cohesion. In red, you can see that the cohesion in the real assignment is greater from the pseudo assignment in both of the condition, although that in the spontaneous herding, the differences are much smaller. Interestingly, though, for the separation measurement in green, participants who were engaged in real assignment during the spontaneous herding exhibit greater separation from the rest of the group compared to the pseudo group, and this effect was reversed in the intentional herding condition. And we figured that this dissociation is logical since in the pseudo groups, there wasn't an actually minimal distance between participants. By reshuffling of the spatial pattern, the distance between participants could also result in zero lag distances. However, in real life, as I've shown you, people during the spontaneous condition chose to maintain greater distances from one another. Moving on, next we conducted a binary mixed model to predict the type of AQ group, high versus low AQ group. The model assigned the participants according to their performance in the task. And we found that directional synchrony and cohesion predicted the dependent variable AQ group only during the spontaneous herding condition and not in the intentional herding condition. We found that during spontaneous herding, the odds of belonging to the high AQ group were significantly lower when directional synchrony increased and when interpersonal space decreased, suggesting that individuals were less likely to belong to the high AQ group as they presented greater herding behaviors. However, during the intentional herding condition, the herding measurement did not predict the dependent variable AQ group. So we could not assess the groups according to the herding measurements in the intentional herding condition. Here you can see the z-scores of all of the herding measurements. So you can see that in the spontaneous herding condition, all of the measurements of herding are lower in high AQ compared to the low AQ group. However, in the intentional herding condition, these differences between the group were found to be not significant. To further understand the relationship between ASD traits and herding, we conducted also a linear mix analysis with AQ group, this time as a between subject covariate, and each of the measurement of herding as a dependent variables. So we've also added the ID number of the group as a random effect, since, as I've previously mentioned, each group has its own specific characteristic that might affect the level of herding. And indeed, we found that different group compositions significantly influence herding. So there was a significant effect for the random variance. The second finding suggested that directional synchrony is affected by ASD traits differently in each of the conditions, so that we found an effect for AQ score in the spontaneous herding condition, but not in the intentional herding condition as before, as I've showed you with the binary mix. And lastly, we found that the AQ score increases the minimal distances, meaning the separation between participants, increased as well in all of the conditions. So here you can see the linear correlation between AQ score and the herding measurements that were found to be significant. So you can see that for the directional synchrony, there is a negative effect between the AQ score and directional synchrony only during the spontaneous condition in blue. In red, this correlation was found to be none. And for the separation variable, you can see that there is a positive correlation. So as the AQ score increases, the separation between individual increases as well across all conditions. So to sum it up, the aim of the present study was to examine group herding amongst individuals with ASD traits. We have found that individuals with high autistic traits are less synchronized with their group members compared to individuals with low autistic traits during spontaneous herding. But this ability seems to recover when herding was intentional, when it was a goal-directed behavior, suggesting that spontaneous group synchronization might be abnormal in autism spectrum disorder. Furthermore, we found that the degree of ASD traits affected individuals' tendencies to keep greater interpersonal space at all times. These findings help us understand some of the basic subconsciously processes that might underlie the profound behavioral disturbances we observed in ASD disorder. We also think that our paradigms provide a highly ecological setting to study social behavior, and also in the future, its neural correlates, which we plan to investigate. And finally, the task we created could possibly serve as an additional diagnostic tool for social difficulties in ASD and maybe in general. So I would like to thank my associates, Dr. Hila Gvirtz, Michael Novat, Matan Karlinsky, and of course, Professor Simon Shamai-Tsuri for her guidance. And thank you all for listening.
Thank you so much, Inbar, for that wonderful talk. And I had already sort of introduced the idea of the effects that we might see in autistic individuals because of the study I was able to conduct with Isabel Jobek's group, using a synchronization task as a proxy for adaptive or coordinating behaviors. This was perfectly complementary to that, so that was wonderful. I do have a couple of questions, and I'm sure there'll be some others coming in the YouTube live stream shortly. But if I might just start, a sort of big, sort of more theoretical question I have, which is sort of overarching in the conference as a whole, is how big does a group have to be, and specifically in humans, to be considered, first of all, a herd? And is it then that only at this threshold that it's likely to behave like a herd? So I'm sort of asking, what is specific to human herding? Is there a threshold for a number of people to become a herd?
Well, it's a very good question. And I guess when you think of a herd, you think of a massive group of a lot of people. But there are studies that show that also in smaller groups, people tend to act as in a group, as a whole. So I don't know if there is a specific threshold, if there is a specific number in which we can define this is a herd, and underneath it's just a group. We figured that when we want to examine these dynamics in a lab and to create an environment to really assess social behavior, we had to, put some boundaries. So we thought that a group of 4 provides the opportunity to, to divide into subgroups. Also, you can do 2 and 2 or 3 and 1. Whereas, if we would go with 3 participants, we could find dynamics that are precluded 1 participant, which wasn't be, especially when you measure ASD, we did not want that situation to happen. So of course we had limitation, but it will be very interesting to examine the same dynamics in a larger groups for sure.
Mainly because I was thinking about what Peter Keller was saying in his talk this morning. I was thinking specifically about, leaderless versus leader-led groups. And I wonder if that's maybe something to do with it. I wonder if it's, because obviously you're differentiating between, in humans, this idea of intentional versus unintentional spontaneous herding. It just becomes quite pertinent, I think, to think about both what Peter said, but also what we heard about yesterday is how we coordinate, computationally speaking, with a number of individuals will vary. And I wonder whether this herding phenomenon is a very different kind of computational mechanism. It's a much quicker and dirtier mechanism. And maybe intentional herding, as you've been calling it, is something altogether quite different and quite unique to humans, which is more energy requiring. It's a much harder job. I do have some questions coming, so I'm going to stop taking over the question time. Peter Keller says, thank you, Inbar, neat and rich study, and a nice distinction between manifestation of ASD effects for spontaneous, not intentional. His question is, do you think it's due to deliberate compensatory strategy or deferent mechanisms? And that was a question I had as well, so that's great.
Okay. So yeah, well, I agree with everything you said, and this distinction between spontaneous and intentional herding, for me, it's quite new. And I think that when you think of leader-follower dynamics, as you've mentioned, they are much more evident during intentional herding. I can say it from observing the participants and from being there during the experiment. I saw that when you explicitly ask participants to herd, they look for a certain dynamics. So it could be that some will lead, some will follow, and this dynamic may change. So one will follow and then he will lead. And when you think about the spontaneous herding, I think it's much harder to see any specific dynamic. And I think the intervals of synchronization occur without any specific intention. It just happens, and therefore you cannot observe any, models of leader and follower or something that is more, planned.
No, I think that sounds about right. We have another question coming in from Patrick Nalepa, who is also joining us from down under in the Antipodes. So he's also staying up late for your talk. He says, this makes me think of Cousins and others' work about leaders or influencers that steer groups. What are plans to increase sociality using this paradigm, if there are? So that's his first question. And then there's a follow-up, I think, which says, it reminds me, groups are homogenous in their ASD trait compositions, he's asking, if that's okay.
Okay, so I'll start by saying that, well, I thought of using this task as sort of a training task, and maybe do like an intervention using this task to see if it increases sociality. Whether you can improve your spontaneous or intentional herding skills. Is it doable? I haven't examined this yet, but it's very interesting in my opinion. And remind me the second question. I think
he was asking whether in your groups that you tested, whether they were homogeneous in their ASD trait composition.
Oh, so no, it's very important to stress. This is why we had the random effect that we've examined, the component of different compositions. We did not control for the different composition. Therefore, we had distinct variants of, you know, high and low, only high, 3 and 1, and etc. And well, for me, it is interesting to examine the specific composition and how it affects the ability to sync, but we didn't have a larger sample to examine each one of the composition, but it is really interesting to see it in the future.
Fantastic. Okay, well, on that note, we're going to have to bring that to a close. Patrick says thank you. I say thank you. He stayed up for herding research. We're all very, very pleased that you could present to us today. So thank you, Inbar. And we have